Okay, so if you're seeing my screen, it says find LRAM for the area under the curve f of x equals x squared plus 3 on the interval 0 to 4 using 4 rectangles. So that's A, that's B, that's N. And your delta x is B minus A over N, 4 minus 0 over 4, which equals 1. That's the width of the rectangle. You have to include a sketch. So you have to kind of remember, well, what does this thing even look like? Which could be easy or hard depending on, comfort level with this. So because you need a sketch and because it's a quiz, I guess I might have spent a little more time here just getting my values. Like this is 3, 1 is 4, 2 is 7, 3 is 12, and 4 is 19. And the instructor is maybe looking for those points, not sure. It's hard to make it, it would have to go up 19 space, which I don't have room for here, but you'd want to somehow indicate that 4, this is 419, and this is 0, 0, 3, and potentially all the points in between.
Okay.
Was that part okay, or was there any issues there?
Yeah, that makes sense.
All right. So then actually drawing the rectangles, there's that one. Then this one here, what the instructor's probably looking for is just that you get that point right. So that's 1, 4 there. You hit it again. 2, 7.
I think what I did is I did the right hand, right?
Yes.
Hand.
Yes.
Yeah.
Yes. So if you're doing corrections, you'd want to make a note of that. It's a little odd because it's like, why would I do these versus those? But that's how it is. So this is actually, you can number them, the rectangles. You got your 4, and you're good. Okay, so then to actually find LRAM, your LRAM here is delta x, which is 1, times f of 0 plus f of 1 plus f of 2 plus f of 3. And once you have your 4 rectangles, you're done. You don't have to keep going on that.
Okay.
And you have those values. That's from this table here. That's 3 plus 4 plus 7 plus 12. So you add them up. What is that? 10, 16, 26. Looks like it's 26. And then, is it an over or an underestimate? It's the best answer is that it's an underestimate because because f of x is increasing and concave up.
So it's under because it's like under the curve.
Right. Okay. I don't know. Like this is like what the official answer is. You can probably get away with saying like, well, it's all the boxes are underneath the curve.
Okay.
This will likely come back on the test. So do you feel more comfortable with how you would do LRAM versus RRAM?
So basically it's the same thing. It's just drawing the, like for RRAM, it's just drawing them like over instead of.
Yeah, we could do RRAM if you wanted on this to draw the picture and do a lot of the same things if you wanted.
Yeah, we can do that. Sure.
Okay. So let me grab this. Okay, we're just going to change this to RRAM. Okay, so I'm going to make the table again, but this time you don't need 0 because you're not going to use it. So we can throw it in there, but you're gonna reuse some of the values. We need 1, 2, 3, 4, and 5 because we need 4 because we need 4 rectangles. So that was 4, that was 7, that was 12. I'm sorry, did I use the wrong values? No, okay. Okay, sorry, I'm just losing my mind here a little bit. Okay, there we go. So now what you care about is the graph, and rightly so. So the graph here, just we're drawing it like that. That's not really good. It's not right. It's steeper than that. Let's do something like that. So this is your 419, but this time you're going left with it for RRAM. I think that's where the confusion comes. You draw it left, but it's RRAM because it's a right hit. And then this point here is 312.
Okay.
And then this point is the 27. Again, it's not to scale.
1, 4.
1, 4 hits it there. Okay. So then your RRAM is your delta X, which is the same again, times F of 1 plus F of 2 plus F of 3 plus F of 4. So it's 1 times 4 plus 7 plus 12 plus 19. 23, 4, so 42. And this of course would be an overestimate.
Okay. Makes sense.
Okay. Can we move on to 2, or do you have more questions about what we just did there?
No, let's go to 2.
Okay. 2. Okay, so they give you this, and then the first question is this, which I'm about to snip in. So it is all about like knowing your properties, and the first property is that you can sort of distribute this and make 2 integrals, f of x dx same bounds plus integral 5 dx from 0 to 7. And did you do that? Yes, you did that. Okay, fantastic. So then this first one is just that they give you that value. It's, well, actually, no.
Oh, they don't give you that one.
Yeah, that one you have to actually break up and say, oh, it's like going from 0 to 4 and then from 4 to 7. So if you needed to show all this work, you could, but it's this plus 4 to 7 f of x.
I think I got that one right, if I remember.
Yeah, looks good to me here. So it's 10 plus 13 plus, now this one.
That's the one they give you, I think.
Yeah, you have to do this on your own, and if you recall, it's a graph. This is the line y equals 5, or f of x equals 5, and you're finding the area from 0 to 7. So it's, I think, and what you wrote here looks good to me. It's 7 minus 0 times 5, which is 35, which is 58.
Yeah.
Okay, so the next one is the one that's a little bit more complicated, but it's the same.
I think I did it right. I just made a calculation error, like 13 times 3 or something. I think I messed up.
Okay. Yeah. So like depending on your comfort level, you can do all of the properties at once. You just do them one at a time, but you for sure want to say, okay, it's integral 3 f of x dx minus integral 4 to 7 2 g of x dx, and then you're supposed to bring the 2 out, and you're supposed to bring the 3 out. So it's 3 integral 4 to 7 f of x dx minus 2 integral 4 to 7 g of x dx. And then we go back and look at our given values. So f of x from 4 to 7 is 13. Like you said, this is 3 times 13 minus 2 times 5. Yeah, 5. And so whatever that is, 29. Okay. Is that okay?
Yes.
All right. It's always, so when the instructors circle, I don't know, like I don't like circling things, because then it leads me to think that there's something wrong. But it looks like the way your instructor does it is they circle the right answer if you have it.
Yeah, he like makes like a big circle, like in ink.
Yeah, so your graph is good here on the right. on your paper. But if you were to try and graph it quickly, you say, oh, there's 2, 4 is the either the min or the max, and this number out in front is your slope. So you got I probably should do this a little bit more accurately since we got grid paper. Let's do it there. Get rid of that. Get rid of that. So sorry. Sometimes I need to just do it nicely. So we have 2, 4, and then it's got a slope of -1 going to the right. And then it's got to be a mirror image. So you have the same image on the left here. Now, because we're going from 0 to 6, you can stop right here. You could go further if you wanted. And that hits there at 6. So that's how you got your nice graph there. And then you don't actually have to do anything other than write out the answer after you write your formulas here. My recommendation would have probably been to make 3 regions, 1, 2, and 3.
Yeah, I think what I did is I just like thought it was a triangle, and then that was all right.
So if you're want to be that student where you go above and beyond, you could make a big triangle and then subtract out this section. But area 1 is 2 times 2 plus area 2 is 1/2 2 times 2, and area 3 is base times height. It's 1/2 4 times 4.
Okay.
And then just write numbers 4 plus 2 plus 8, 14.
So close yet so far.
Yes. Well, there's all this pressure, and a lot of things happen when you're in a testing environment that don't happen otherwise. As always, if you want one like any of these, just let me know.
Okay. So far, so good.
Yeah. So this, like when I look at this here, like this really should be in parentheses just for for clarity. You might have chosen to break it apart, integral -1 to 3 x dx plus integral -1 to 3 dx. That would have been okay.
I just didn't know what the antiderivative was.
Right. So the antiderivative means like whatever you choose, like let's just say you chose it to be x squared. When you take the derivative of this, it has to be that. And it's not.
Well, like I know what an antiderivative is. I just didn't know like what it was at that value. Yeah.
Oh, okay. Okay. So, and then you got notation like this, which we can talk about. This one is 3x because the derivative of this gets you back to 3.
So it's x squared over 2?
Yes.
How does that turn into x?
So the another way to write this is, of course, 1/2 x squared, and then y prime is 1/2 times 2x to the 2 minus 1 power. That's the power rule. So those cancel, the 1/2 and the 2. Like that becomes the 1, that becomes 1.
What is the antiderivative of x squared?
All right, so it's 1/3 x cubed, because the derivative is 1/3 times 3 x to the 3 minus 1. And that becomes just x squared.
Oh my God, so confusing.
Okay, so we talked, like I think I wrote this even down once or twice, I hope, is that the antiderivative of this is x to the n plus 1 over n plus 1. So you take whatever's here, which in your case was a 1, you add 1 to it, and then you divide by the new exponent.
Oh, okay.
Okay, so this is all really important on the right here, but let's assume you got the right antiderivatives now. Are you comfortable evaluating the antiderivatives? It's always top minus bottom.
Yeah, so it's just 3 squared, so that's 9 over 2. 9
yeah, so 9 over 2 minus
1, yeah, 1/2.
Okay, plus 3 times 3.
9 minus 3, so 6. Oh, plus 3, so 12.
Yes, so plus 3. So you get whatever this is. This is 4 plus 9 plus 3, which is 16.
Yeah.
We should do another one of these, if you're okay with that. If you're not, we can move on. Actually, 5 is related, so let's do 5. Or we can do one just like 4.
We can do one like 4.
Okay. So I want the integral from -2 to 1 of x of 2x plus 1 dx. And I want you to use antiderivatives. So you got to figure out what function's derivative gets you back to 2x.
X squared, right?
X squared.
Okay.
And then you can evaluate that from -2 to 1.
Yeah.
What function's derivative gets you back to 1?
1x.
1x. So just x. Now there's actually a choice here. Like this is correct on the left, but you can also do it together so that you're evaluating the whole thing from -2 to 1.
Okay.
And as you progress in the course, you'll find that this is the preferred approach. It's less writing because it's 1 squared plus 1 minus -2 squared plus -2.
-2. It's top minus bottom, right?
Yes, it's always top minus bottom.
Plus 1 minus 4 plus 3 I got 0.
For which one?
The
Are you doing the left or the right version of this?
the left.
Okay, so let's try this. It's 1 squared minus -2 squared.
Yeah, got
So that's
that.
1 minus 4. Okay.
Yep.
And by the way, that's this part right here. Plus 1 minus a -2.
So 1 plus 2.
Right.
So 3.
3. Yes. Yes. Sorry. I was, yeah. This is a plus. Yes. So it is 0.
Oh, okay. Wait, so why on the left you didn't get 0? I mean, on the right you didn't get 0 though.
Because I didn't put the parentheses around it like I was supposed to.
Oh, okay.
It's just negligence, really.
All right.
So that just to be clear, like this, if you haven't already gotten there, this is like you're going to use this all the time in this course, and maybe calculus too if you take that next year in college or whatever happens. Like this is really important to remember. And there's actually a bit more to it that I've excluded. Okay. So here is the next problem on your quiz. And if the average value is always 1 over b minus a, the integral from a to b, f of x dx. And notice you're given a, you're given b, and you're given f of x. So it's 1 over 6 minus -4, integral -4 to 6, 2x plus 3 dx.
1 over. Okay. Did I don't think I think I got 1 minus 1 over b minus a, but I don't think I did the integral part right, maybe.
Right, right. So average value is just a way of saying like, find the integral, but then it truly is an average because the distance from these 2 points is 10. So it's dividing the total area by 10.
How do you do the integral of that?
Okay, so this is 1 over 10 out front.
Yeah.
And then again, it's like, well, what derivative gets you back? What do you take the derivative to get back to 2x?
X squared.
X squared. What derivative gets you back to 3?
3x.
3x.
Oh, and then you evaluated it. Oh, that's so simple. I made this so much more.
It is. Once you get past whatever obstacle barrier there is, like, oh yeah, it's just putting numbers in. So this is 1 over 10. I would deal with that last. 6 squared plus 3 times 6 minus, and I'll be very clear, this is a parenthesis, big one here, because you're putting this is the top and then the bottom.
So it's 36 plus 18 minus 16 plus or minus 12. So then that's 2. Minus 12, negative 10, 26. Oh, what?
So the sign of like did you get this line here?
Yeah.
Because the okay, so I mean, when you add this up, you get 50.
Oh, wait. Shouldn't it be a oh, I see what I did wrong. I put minus 12 instead of plus 12. Okay.
Would you like to do one more just similar to this?
Sure.
Okay. Do you want polynomials, or can I vary it up just slightly?
You can do it a little different.
Okay, so the average value from 0 to pi f of x equals cosine x plus x. Yes. Yep,
So
this would
it's
be good.
1 over pi minus 0.
Okay.
Pi or integral from 0 to pi of cosine x plus x. And then you do cosine x plus x evaluated at 0 and pi.
So what did you get for your antiderivative of cosine whenever you?
Oh wait, I need to do that. The antiderivative is it sine or negative sine?
It's sine. So you gotta know these really well. What if you start at sine, the first derivative of cosine?
What's the one that's negative sine?
So next derivative is negative sine x, and then the third derivative is negative cosine x, and then it comes back. It's very similar, like I squared, I cubed, and so on.
And then x is the x squared over 2.
Yep. And you're evaluating that from
0 and pi.
0 to pi.
And then it's sine of pi squared over 2 minus sine of 0 plus 0 over 2.
So as a reminder, on your unit circle, sine is the y value, and you're over here.
So negative or 0.
0.
0 plus, how do you do the pi squared?
You just leave
2?
it.
Okay, can I leave it as pi squared over 2?
Yes.
Or, okay.
You still got this 1 over pi out in front, but sine of 0, 0, 1/2 0.
So it's just 1 over pi times pi over pi squared over 2. And then that cancels that. So it's just pi over 2.
Exactly.
Okay.
Great.
Okay.
All right. Is there any other questions this quiz you would like us to do again? Vary the example of.
No, I think I'm good on that.
Okay. All right. So I see 6-4 day 1, 6-4 day 2, and then 6-5. Is there anywhere you'd like us to start looking today?
I guess just start with day 1. I have another lesson scheduled tomorrow, I think so.
All right. Yeah. And would you like me to like look for questions to then give you questions about?
Yeah, we could just do like related questions or.
Okay. Sure. So fundamental theorem of calculus, it's kind of I don't know, it's not as like exciting as I think you would think it might be. But sometimes, so let me do this. So they sometimes start by saying f of x equals the integral from a to x f of t dt. Maybe you saw that in your notes. And then the first thing they always ask for is, well, what is df dx? And it's d dx of the right hand side. And you're like, well, wait, what does that even mean? So I thought we could do a few examples of this to start. We can even do the ones that are there and then make some up as we go, if that's okay with you.
Okay.
It's more complicated than it looks than an actual practice, and I'll go through all the possible scenarios that you might see. So if you see this derivative thing out in front of the integral, the first thing you do is you take whatever this top value is, which should be an x. There has to be a variable at the top, by the way. There has to be a variable at the top. You put that variable or whatever is there, because it's not always a variable, into the function. So this x goes right there. So you write cosine x. Second thing you do is you multiply by the derivative of the top limit. So the derivative of x is 1. Okay, so we're gonna make this slightly more difficult, but like it's gonna be the same set of steps here. You take whatever's up here, and then you put it in here, and then you multiply by the derivative of this. So let's do one that's like this, but we're going to change it up just slightly. This is your next example here. So you take whatever's up here and you put it in for the variable.
Cosine x squared.
Yes, and then you multiply by the derivative of this.
2x.
Now, most of the time, well, of course, in the beginning examples, the derivative is going to be 1, but on a test, it might not be.
Where was it? What? Oh, the
derivative of x is 1 here in this previous example. So let me do.
Isn't the derivative? Oh, that's the antiderivative. Never mind.
Yeah. So that's another thing that's going to be very confusing, is going back and forth to antiderivatives and derivatives.
Yeah.
So d dx integral from 1 to x squared plus 3x minus 4 of sine t dt. Okay, so whenever you see this out in front, what you do is you take whatever's up here and you plop it in for the variable that's in this. And And let me just, yeah, so we'll keep going here. So that makes this the sine of x squared plus 3x minus 4 times the derivative of this, which is 2x plus 3.
Okay.
Is that okay so far?
Yes.
Okay, so we're not going to keep doing this kind of example because we need to move on to other variations on this. So the other variations are, well, what if there's more than what if there's more than one variable? Well,
You
you
do the
take,
chain rule thing, right?
well, you put it in both places and you still have to multiply by the derivative. So this becomes square root of x, e to the square root of x times, what is the derivative of
Ugh.
square root of x? And it's x to the 1/2. So I'm trying to remind you of a few things.
I kind of forgot how to do derivatives now.
Okay, so if y equals x to the n, y prime is bring the variable down nx to the n minus 1 power.
Okay, so 1/2 x, what is it? Yes.
To the minus 1/2. Okay, and so you can actually simplify here, like this right here is really 1 over 2 square root of x, because the x to the 1 minus 1/2 x goes to the bottom, and then these cancel, so you end up getting 1/2 e to the square root of x.
Okay.
So very important though, like very important is this recipe. Like you always do the same thing. You take this, you put it in the variable, and then if its derivative isn't 1, you have to figure out its derivative and keep multiplying by it. Okay, so like the instructors could make it, your instructor could be very difficult, and I have no idea, but like, and also it doesn't even matter what's down here. This could be like minus pi squared plus e plus natural log of 45. It's a number. This down here is a number. It doesn't matter what it is. 1 over 1 plus x, and then we'll go sine. Actually, let's do natural log of t dt. So again, it doesn't matter what's down here. This is just a number. Okay, this, you take whatever's up here and you put it into the variable. But then you have to multiply by the derivative of this. Do you remember the derivative of 1 over 1 plus x, or how to do that?
1 over 1 plus x. Nope.
Yes. So it's not quotient rule. It's literally 1 plus x to the minus 1 power. So it's actually just power rule. You just bring this minus 1 down. 1 plus x to the minus 2 power.
Yeah. Oh my gosh, I need to review like quotient rule and stuff. All this is
yes. Now it doesn't look like the instructor's gonna go crazy with like all the rules, but they could. I mean, they totally like can say like, yeah, we'll put anything we want in here. I guess the instructor kind of does that here in the next one.
Can you go over those? Like,
yeah, we're gonna do that. There's another. So the next kind of variation on this is, well, hey Matthew, what happens if the thing is on the bottom? So let's say it's x to the 2/3 power and it's 1 up here. What do I do? And this is x minus cosine x. I'm sorry, t minus cosine t dt. So well, what do? So you really need the constant to be on the bottom. So you can flip the limits, but if you flip the limits, what does that do? Do you recall what that property was from before?
If you flip the limits, isn't it just like it makes it like negative or whatever?
Yes. So you can choose to put the negative on the outside, or you can distribute that negative in here if you want it.
Okay, so if you put it on the outside, you'll just do it last, basically.
Yeah, it's t minus cosine t, but it still applies. Like you have to run it through the problem.
X the 2/3 minus cosine 2/3 and then all like with a negative out in front.
Yep.
Yeah.
And then you have to multiply by the derivative of this. And that's power rule again.
Okay. 2/3.
Now you could be asked to simplify, but that's not kind of what we're trying to emphasize here. So
how would you simplify that? That's what I was looking at.
sure. So let me not try to do too much at one time. So it's cosine x to the 2/3. I'm just distributing the negative minus x to the 2/3 times 2/3 x to the minus 1/3. Okay, so the first thing is that when you distribute this, you can actually put the 2/3 just out in front. That's a common thing to do. And then it's x to the minus 1/3 cosine x to the 2/3. But here, when you multiply these, you add the exponents because the bases are the same. So it becomes minus x to the 1/3 because 2/3 minus 1/3 is 1/3.
Okay.
And this is about as far as you could go on this. Okay, so see if you can do, I'm going to make a small change to this one that's on your, that was given in your class, but it's very similar. Let's make this go, let's go x squared to 5. So it's really similar to the last one. You got to flip the integral. You got to put the variable in the function, and then you got to multiply by the derivative. So give that one a try on your own, please.
Okay. So it's 3. So the number on the bottom of the integral doesn't really matter at all for these?
No, I'll try to explain that next, like kind of as we build up to
Okay.
it. It could be anything. This could be 5 pi, could be 5e, could be, you know, -5, -5 billion. It doesn't matter.
How do I do, is it -5 or just 5?
It doesn't matter. It could be anything because the negative is going to go out in front. When you flip this to whatever this is that goes down here to x squared, you're putting a negative out in front.
Wait, why do you have to flip it?
Because you always want the variable on the top.
Oh, okay, wait, I already did this wrong then.
Okay, sorry. So in the previous problem, like we have to put the function at the top.
So this one would be 3x squared sine x squared negative, and then times times x cubed over.
You're doing a antiderivative instead of derivative of that.
2x.
2x, and that's it.
-3x squared times. Yes, okay.
Take that there, and then you multiply it by the derivative. So if you're to simplify, it would be like -6x cubed sine x squared.
And the antiderivative of x squared is that's the one that's x cubed over 3.
Yes.
Okay.
Yeah, like maybe, so I mean, you're at a point now where you can definitely like have these side by side. So the derivative is nx to the n minus 1, but the integral of x to the n dx, let's say this is y, then big Y is x to the n plus 1 over n plus 1.
Okay.
And you can see how they sort of like if you take the derivative of this, you go back there.
I feel like I forgot all my derivative stuff over
Yeah,
break, and then
it's
we haven't done it all semester really. So
let me see if I can find something here I posted that I think might be helpful. It was this exact concept. Yeah. So let me see. You can say this. You could look at this later in your notes, but basically, you're starting out with the derivative is like going forward. That's what you've been doing all along. So you know this power rule, and then when you take the derivative of this function, you get just x. And the integral is basically just going backwards. It's going this other direction, and you're starting out with what you found the derivative to be, and you're working your way back to get the original function.
oh, okay.
All right. Okay, so we need to do a bit more on this topic.
What is the one with like the chain rule stuff? Is
We've
that maybe that's in the day 2?
We've been doing that. We've been doing that, but let's do that. That's the whole, like, you got to multiply by the derivative.
Oh, okay, okay.
That's the chain rule stuff. Okay, but there's another example here. So let me try to explain using an example we've been doing. Let's just say it's e to the x from 4 to natural log of x dx.
Well, now the exponent's on the top though, so
yeah, that's okay. So here, like I've been not giving you the full information here. Okay. So here's what you're actually supposed to do, and this is why they cut it out for you. You're supposed to actually put the top minus the bottom. So let's do the top. E to the natural log of x times, what's the derivative of natural log of x?
just it's 1 over
X. Good. Minus, you put this in here, e to the 4th. What is the derivative of 4?
4x. No, that's the antiderivative.
Yes.
0.
0, right? What is anything times 0?
0.
So this whole thing goes away. That's why you've just been focusing on this.
I see.
Okay, so now let's do a similar problem here, but let's go integral x to natural log of x, e to the x dx. So now there's a function on the top and the bottom.
Okay.
So it's always been, we just have been ignoring this. It's always top minus bottom, but now
but now you have to do the bottom too.
Now you have to do the bottom.
Okay.
So it's e to the natural log of x times the derivative of natural log of x is 1 over x minus, I'm sorry, these should be t's. Get some violation by our instructor on that. So that you take x and you put it in here, so it's e to the x times the derivative of x, which is 1.
Okay.
And this does simplify. E to the natural log of x is x. And then x over
and
x is just 1.
Out.
Yes.
Just 1. Okay.
So let's look at your example from class because it's really similar. Let's see if you can do this one without looking at your notes. It's like the last one I did. You have to evaluate top minus bottom.
Okay, so, oh God, 1 over 2 plus e to the x squared.
Oh my gosh. I apologize. My window just closed.
Good.
We'll get it back.
Two plus e to the 2x. So this one you don't have to multiply by the derivative, or you do?
Oh, you always do. So this is e to the x squared times the derivative of x squared, which is 2x.
Okay, and then the other one is just 2. So then,
Yes.
that just becomes x over, no, just 2x over 2 plus e to the x minus 2 over 2 minus e 2x. I don't know how to simplify that anymore.
There's not much to do here. You just write the numerator. And then over here, I'm sorry, it's 2 over 2 plus e to the 2x.
Can you combine them or no?
No, because you'd have to make the bottoms the same, and it's hard to make x squared and 2x the same. Could be done. It's quite.
Oh
quite
wait,
awful.
I forgot that it's different
Yeah.
exponents.
All right, so let me try to just summarize the types that you're going to see on this. So I'm gonna write it this way. The first type you're going to see on a potential exam is number to function of x. Actually, let's just do x, because that is kind of the first type. You're going to say x, and then you have a function of t dt, and this is always whatever you just take x and you put it in for that. That's the first type you might see. We'll call that type 1. Type 2 is it's really a function of x up here. Like for example, it could be like square root of x or x squared or sine x or whatever. It's going to be something. But you take whatever's in the top and you put it in wherever you see a t. So this becomes let me use a different letter. Let me use g for that. So it becomes g of f of x, but then you multiply by the derivative. And let me just try to give you an example. This is like the integral of from like 4 to x squared e to the t dt. So you take this and put it in here, but then you multiply by the derivative of that.
E to the x squared times 2x.
Yep. The next variation you might see is where they give you the wrong order. So it's either like x or f of, sorry, the number is now up top. It's either like x or it's f of x down here. And when you get one like this, you have to remember to switch or flip the integral. And then it goes back to the previous one.
And then if you flip it, it has a
negative in front. Yep. And then the last type you might see is when you go from like they usually write it this way, f of x to g of x, and then it's like p of t dt, and this is that top minus bottom with chain rule.
Okay.
And that's like that last example we did there.
All right.
Okay. We got a lesson tomorrow, so we can pick up here, or if you got new stuff, we can certainly look at that.
Just do the day 1 of the 6.4, or did we get through?
That is all. Yeah, that's all I got through.
Okay,
I did get all the way up through the last slide. So we're totally
okay, yeah,
good.
because there's only the other half, and then the 6.5 is really short. So
thanks so much for scheduling, and I'll see you tomorrow. Have a great night.
thank you.
Bye now.